So to be able to interpret and analyze the slope of a line, we can do that and we can interpret it as a unit rate. That's what our table of contents will tell us, analyzing and interpreting slope as a unit rate. So first, let's think back into our memory banks. What is unit rate? It's what? It's something? You're right, it is something. Okay, what about if I told you I'm going to go to the grocery store when I get off of work and I'm going to buy 5 bananas for $5? Actually, that's kind of expensive for bananas. But if 5 bananas cost $5, how much does each banana cost? $1, because all 5 of them cost $5. So the price of 1 banana would be $1. That is a unit rate. A unit rate is always talking about a quantity of 1. So a unit rate is always talking about a quantity of 1. So we've learned how to find the slope of a line, but now we need to figure out, well, what does that really mean for us in everyday life? How does that apply to what we do every day? So let's take a look at this question. I know on your paper the little lines, the grid lines don't come out very well, but we're going to do them together up here on the board as well so we could follow along. So first question it asks us, what is the slope? Well, if I'm going to find slope from a graph, how do I find slope from a graph? What do I need to do? Rise over run. Rise over run. And we know rise is the change, the vertical change. Run is the horizontal change. Rise over run. So now let's look at this. I can pick any 2 pretty points. I'm going to pick this point here. They gave us 3 different ones already on the graph, but I'm going to pick the 2 far apart ones. So I could kind of make my little box, my little triangle box to kind of help us out a little bit. Those are kind of like our guidelines. Now, yesterday when we were counting slope, we were counting each box with a value of 1. It went up 1, 2, 3, 4 boxes, so that was our value. But look at this y-axis. What is each line on the y-axis? How much is each line? What are we counting by? We're counting by, not 14. If 2 lines is 24, that means in between it is 12. So we're counting each block represents a value of 12. 12, 24, 36, and so on. So now if I know that each block represents 12, my rise is going to be 12, 24, 36, 48. So my rise is 48. Another way that I could see that, if that's a little bit hard to count, is when I come over here, I started at 48. After I was rising up, I ended up at 96. 96 minus 48 is 48. Now I need to count my run, the change in my horizontal. Well, if I look at my horizontal, my x-axis, what is it counting by? 1. It's counting by 1, so that's really easy. 1, 2, 3, 4. So I have my slope at 48 over 4. Can I simplify that? I can. It simplifies to 12 over 1, or we can just say 12, because we can simplify it to an integer. So that's kind of reviewing what we were learning, finding slope of a line. Now what I want you to look at is this question right here. What is the cost per hour to rent a canoe? We're going to be looking at the graph and reading the graph. Per hour means how many hours? Per means what? Per is how many hours? 1 hour, 5 hours? Each hour is another way to say it. So how many hours would that be? 1 hour. So I'm going to go down here and I'm going to look at my hours and I'm going to find where the x value is 1. So when I find where the x value is 1, I'm going to go up to my graph. So that 1 hour corresponds with how much money? Where does it line up with how much money? It lines up with 12. So it cost $12 per hour to rent a canoe. $12 per hour. So now the last question, what do you notice about the slope and the unit rate? They are the same. They are the same. And that's what's really cool about proportional relationships. If your graph goes through the origin, your unit rate will always be the same as your slope. Your slope will always be the same as your unit rate. Because if it's the cost for 1, it has to be that same rate for 2, 3, 4, and 5. It's constant, right? So since a proportional relationship has a constant of proportionality, slope will always be the same as the unit rate. Slope will always be the same as the unit rate. It'll always be the same as the unit rate. All right, so let's look at this first graph that you have in your notes. The graph below shows the relationship between the number of hours and miles driven for the Griswold family vacation. So Clark is loading up his family. They're going on a road trip. And Clark Griswold. Huh? No, that's the name of the characters from the National Lampoon's Christmas Vacation.
Oh, yeah.
Clark Griswold. All right. So the first question wants to know, what's the slope? All right. Whoops. We want to find out what is the slope. How do we find slope again? M equals rise over the run. And if it helps you to put the arrows so you know which direction, you could do that. Notice we have the arrows also on the board, rise and run. All right, so we're going to pick 2 pretty points. And again, I know it's super hard to see the line on your paper. But I'm going to pick the bottom 2 points that they have listed. So how far did I rise up? Because I had to just go 1 block. But is it really 1? It went up from 120 to 180. So it went up 60. And then my run, it went over how many? 1. So I went up a value of 60, I went over a value of 1. So 60 over 1, my slope is 60. Now, yes. Yes. I could have went to the third one. Remember, all it takes is 2 good points. It doesn't matter which 2. You still would have got the same. If I would have went from here to this point, it still was up 60 over 1. All right, so now we're just going to read the graph. We're going to read the graph. How many miles were driven in 1 hour? So I'm going to find my 1 hour on the graph. I'm going to go up. That corresponds with how many miles? 60. Again, what do you notice? What happened again?
They're driving at 60 miles per hour.
They are at the same. It's 60 miles per hour. My slope, remember, slope is a constant rate of change. So it's a straight line, so I'm driving the same speed, and it's 60 miles an hour every time. So my slope is 60, the same as my unit rate, the same as my rate of change. Yes? The cost, or it deals with a quantity of 1. So in this case, the unit rate was for 1 hour. All right, let's look at the next one. The graph below represents the relationship between the distance a sloth travels over time And a point on the graph, what point on the graph represents the unit rate? This is the one I think that's super faint, but you can see it up here. So if I'm going up here and I just want to read the graph, a unit rate means I'm always talking about how many? One. So my unit rate is always where my x value is 1. So 1 minute. So if I follow that all the way up, this point right here is my unit rate. That point of 1, 6, because it lines up with 6 over here. That is my unit rate. That point represents the unit rate. Now, what does that mean in terms of the graph? What does that mean about the sloth? What does the unit rate tell us? How fast can the sloth travel? 6 what? 6 feet per minute. So a sloth will travel 6 feet per minute, or 6 feet in 1 minute. In 1 minute. Now, because I know the unit rate, what's the slope of this line? 6. It's the same as the unit rate. So I already know that the slope is going to be 6 over 1 or 6. I already just know that by default because it's proportional. All right, let's look at the next one. The graph below represents the relationship between money saved over time. How much was saved each week? Well, here, each week would be 1 week, but is that on one of my grid lines? Is that a good point? No, it's kind of like right here. I could probably estimate, but I don't know for sure. But because this is proportional, what else could I calculate that will also give me a unit rate? Not the 2. I could find the slope, right? Isn't the slope the same thing as the unit rate? Because it's proportional? So let's find the slope. I'm going to change over to red so it's a little bit easier to see. So I could just find a good point. 2 good points, that works. How far did I have to rise up? I went from 94 to get to 188. How far is that? 94. It is 94. So if we're doing rise over run, our rise was 94 over, how many did I have to go over? 2. Notice we were going from 2 to 4. So that has a value of 2. And that simplifies the what? 47. Let me show you how to simplify that in your calculator in case you don't know. Everybody put 94 over 2 as a fraction in your calculator. 94 over 2, 94 halves. And then just hit the enter button. What does it do? It gives you the answer, 47. If it was still a simplified fraction, it would give you the simplified fraction. But because 47 over 1 simplifies to an integer, it's 47. So if that's my slope, what's my unit rate? How much did they save each week? $47 per week, or each week. Per week, each week. All right, before you glue this in, let's do a few more problems that I pulled. Let's see if we can practice, before we glue it in, let's practice interpreting a graph. An aquarium is being filled up with water. The graph below shows the height of the water over time as the aquarium fills up. How much is the water increasing per second? When you see the per second, that means how many seconds? 1 second. Do I have 1 second on my graph? Yes. Yeah, right here. So if I follow that up, its point corresponds to this line. Well, I know if the second line is 5, what does that first line have to be? 2.5. Halfway between 0 and 5 is 2.5. So it is filling up 2.5 inches, and I'm getting it from my label, per second, because it's coming from my label. 2.5 inches per second. What's the slope of this line? 2.5 over 1, or 2.5. Now, I will tell you, the unit rate and slope only works if it's proportional. If your graph was something like this that didn't start at 1, I can't say that it's got the unit rate. It's not going to be the same. Okay? Today we're only talking about proportional relationships. All right, what about this one? How many books are sold per day? Now this one's really tricky because, first of all, what are they counting by on the y-axis? Well, 2 blocks is 1,000, so 1 block, that would be 500. But per day means 1 day. So if I go to 1, is that exactly on 500? No, it's not. I don't know what to estimate that. I know it's less than 500, but if I need an exact answer, what could I do to find it? What could I calculate in order to find it? I have a proportional graph. Unit rate's the same thing as what in proportional graphs? Go back and look at the first page of your notes. It's the same as the slope. Could I calculate the slope to find out how many books? Yes, I could. Okay? So that's just a way that you can use 2 different strategies to try to answer these questions. Let's look at the next one. It's the last one we have. This was pulled straight from an old test. If Dante's neighborhood grew 18 inches after the first 2 years it was planted, which graph best represents the tree's growth rate per year? Well, we have data in our problem, right? We have data in the graph. Let's first see if we can find out what we know. Before we start doing our calculations, maybe it's already here for us. 18 inches corresponds, how long did it take to grow 18 inches? 2 years. Do I have 2 years on all my graphs? I do. I have a 2 years here, 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 and here. Well, let's see. Do I have any of them that match up with 18 inches? If I go up, does that line up with 18? Nope, it goes 36, so that's not it. What about H? It just goes straight up. No, don't know what that is. All right, what about G? 2. It matches with 8, so let's double check and make sure. What about this one? What did it line up with? 72, so I know that's not it, so it is G. So see how sometimes you just use the data we got. Now, if we know that it grew 18 inches in 2 years, can you think about what would be the unit rate? How much did it grow in 1 year? 9. What's 18 divided by 2? 9. So it grew 9 inches per year. And look, it tells us that also right here. 1 year would be 9. There would be our unit rate. So what's the slope of that line? The slope would be, slope is the same as what? Rise over run, but it's also the same as the unit rate. So the slope would be 9 over 1, or 9, because our unit rate was 9. All right, go ahead and glue your notes into your spiral, please.